All right, welcome back to episode number 60 of the Piezo SHOCK Show. Um, Today I'm going to answer the question, what equipment is needed to visually measure ultrasonic displacement? Today we're mostly going to be going over cameras, lenses, options there, just kind of everything you need to know about before ordering different components. Now this will be a more general discussion. I am not an expert in terms of determining which lenses and options and cameras there are the most appropriate. However, this will kind of give you some of the fundamental building blocks in case you're kind of lost and some other things you may not have thought about, which are going to be pretty helpful for you. So let's go ahead and dive in to the presentation here. So here we take a look at the equipment list. You're obviously going to need a camera itself. You're going to need lens. Now this is the wrong spelling for lens. It should not be a no need for there to be an E there. I looked that up. So there's lens and slash optics. We'll go over that. The stage, so you're moving your transducer or whatever you're trying to measure up and down for focus, and also to get the right part of your transducer into the measurement. Also lighting, which is actually quite important, and finally software. Once you've made your image capture, how do you go ahead and analyze that picture? So camera, here are some of the considerations and just some general information. This is kind of a brain dump a little bit. It's not so structured and formal because again, I'm not an expert in this area, but I'm just going to give you some tips or just things to think about before you talk to your vendor. So usually when you're looking at scientific style cameras that you might want to use for this, you'll be either looking at a USB or Ethernet connection to your computer. And if you don't have, let's say you're using a laptop and you don't have an Ethernet connection to your laptop, there are plenty of USB-C to Ethernet connectors that will work just fine. So that shouldn't necessarily deter you from using or having to order like a desktop PC specifically to make these measurements. The figure of merit, which is quite important here. First of all, the figure of merit is that what the heck does everything look like once you assemble everything? What is the how good is the image quality with your lighting, with your camera, everything included? That's going to be the most important, obviously, but kind of building up to that and trying to design or at least spec a system that could be the best for you. The figure of merit is going to be microns per pixel. So you can expect like a maximum around 0.2 microns per pixel to kind of be I think that's about the theoretical limit as much as you can get as far as resolution of optical light. The higher wavelength of light you use, you can resolve slightly higher microns per pixel, maybe even going to UV light if you have something special there. But in terms of what I'm using and what I'm doing, it's this basic optic kind of the visual light range, and that's about as good as you're going to be able to get. Even if you do theoretically have better resolution. So your pixel density of your camera in that case is important in order to resolve a smaller distance. Now we don't care about color. Color is not important at all. So if you see a monochrome versus color, you don't need color basically. And cameras that are generally good for machine vision and sold for that application are going to likely work well for what you need to be using. Now I'm going to show you three options actually. Two are like the scientific options, and one is it's a really cheap, widely available option to get you started for sure. All right, so one here, and I'll just make myself smaller. And there are a couple of optics vendors. They include Thorlabs, Edmund Optics, Newport. So this is just an example from Thorlabs, a high magnification zoom lens system for machine vision. So these are all keywords if you're going to be Google searching for different vendors and things. You'll want to use some of these, some of the words that you use is like long range microscope, machine vision zoom lens. Like these type of key phrases are going to be very important. So you see there's a camera, then there's going to be a tube, and I'm talking more about the lens here, kind of skipping ahead. But you basically have the camera that's used to obviously capture the image, and then a couple of optical pieces ahead of that. And I'll just go ahead and start to describe the lens system. That you'll have an adapter to the camera. Then you'll have an extension tube. In my case, the device I have just has the camera system I have just has a 1x long tube, and there's also a zoom lens, which then allows the image to become larger for your camera system. Here's another system that I actually own and have and use, and it works well. This is obviously much less expensive than the Thor Labs version. Just the camera itself here costs probably $5,000, and each of these components cost. This whole system probably costs an order of $10,000. This one costs about $271. It has all the necessary components in order for you to get a decent image. There's a long tube here. So there's a camera. There's an adapter portion which allows you to attach the rest of the lenses. There's a 1x tube here, and there's a zoom lens on the end, and it comes as well with a stand to look at. So I definitely recommend this. I have it, and I'll probably go over in a couple of videos about how I use it to make measurements. But this is a really good option if you want to if you want to do searches for long range microscope or machine vision zoom lens. Those will allow you to come up with a good with some good options there online. And here, as you can see, you can also, this is USB, also DVI if you're going to connect it to a computer. To a screen directly. Let me just hop on Microsoft Edge here. And go to, because I don't use Microsoft Edge, so then it's okay to show demonstrations on it. HUIER, my microscope camera. So that tube is actually going to help you get the long range microscope. So you're not going to be like, because usually, you're used to those scientific microscopes that you look at slides, slides of like bacteria or whatever on. Those are obviously illuminated from the back side. I forget what they're called. Through light illumination or something like that. I forgot. But basically, they're getting really, really close to the sample. Here, you want some distance in order for you to like maneuver around your transducer. You can be up to like in my setup for that specific camera that I was showing. At max magnification, I'm about 6 inches away, so it makes it quite nice for me to. Can move around the transducer without knocking into it in any case. And you can have lighting with different methods, and it's you don't have to worry about a lot of things there, because lighting is so which one is the one I had here? I think it was at 300. So that's the lens. It comes all in one packet here. That's 41. Oh wow, it's 41 megapixels. Anywho, so this is something similar. This is the magnification. Basically, I'll just throw that there. This is the optics on that camera, which ends up getting me. I think it was about it was about 0.2 pixels per micron, so which was pretty good. Actually, it was sorry, I'm drawing a blank here. So it was 19, I think 20 or 80 pixels for 1,000 microns, which was 1 millimeter, which makes it 2 pixels per micron. Something in that order. Yep. So if you do 1 over, so it's 0.5 microns per pixel. Perfect. So that ends up working out pretty well, and I had some images that I took, and I'll show you some of those later. And I'll show you some other options that actually do provide decent. So they do provide decent resolution, depending on how much you're measuring. So if you're measuring 10 microns or less, you are really going to have to pay attention to your camera and get something similar to this style, long-range microscope style. I chose to get kind of a complete system already built up because, well, to avoid kind of components not properly matching and forming a good image. But if you just type in UV microscope, most of these, so these have a lot of false claims, so you'll have to actually evaluate how many microns per pixel you get. And after that, you would be able to determine like, well, can I actually resolve 20 or 30 or 40 microns with this camera? So the ones like that have a stand like this are going to be the better. It's going to be more easier to manage than something on this kind of unstable base. The ones I actually showed in the video, another video that I had, was Teslong microscope. This is the one. So this is the one I actually have used in a previous few videos. And this is interesting because it can go underwater, so you can actually do transducer measurements underwater if you want to put your tip underwater directly. But you have to get pretty close at the same time. So you'll still need to. So it has its drawbacks, but it is $40 versus 300, and the other option if you go for the more expensive scientific grade cameras, you'll be looking at $10,000 for your system. So that was definitely the other option. I think this is a great kind of middle ground, and that's honestly what I use. But I'll be showing that in a couple of videos because I just recently acquired it. So we talked about the lens a little bit. You're going to be using a long distance microscope system. There'll be a C-mount attachment, a tube, which is going to get you the larger range, the focus range will be in my case is 6 inches, about 5 to 6 inches away from your camera, so that just worked out really great. And obviously the zoom lens, you'll tend to zoom out in order to get your device in the screen, and then you'll zoom back and you'll zoom in and you'll adjust the height of the camera in order to properly bring your transducer in focus. Now let's talk about stages. All right, this is actually quite important. How you align and get your transducer in view. Because the z-axis, or the axis in plane of your camera, is going to be quite important because, well, that's how you get your focus image. And the rest of it is in order to maneuver your device in order to get it to you viewing the right portion. You're honestly going to be looking at the tip of the transducer, which has the most displacement, so you can get the highest amplitude, so you can get the best measurement. So there's a couple of things to think about there. So one is, how do you set all this up? One is to use an optical table, which I didn't show. Let me just go ahead and open this up. I don't think they have it on Amazon. But you never know. So okay, I'll go ahead and skip to the stages here. So these are either millimeter or inch precision stages. These are just one direction, X. This is a good one here. I personally use this. It works really well. And it's a Z stage, and it's kind of precise. So this is very good for going up and down. And this is good too because this is going to provide you angles. In order, so instead of turning your whole transducer, you can mount it in a way which is normal or natural for the transducer, and allow the stage to kind of compensate as needed. So there's a couple tilt stages here, but there's no traditional optical table. I think eBay's a better place for optical tables and shopping for that kind of stuff. I mean, if you want to get a secondhand version, or you can obviously go to Thor Labs. Let me see if they have a good picture of a small one. Like this is okay. So optical breadboard. Sorry, I didn't mean table. I meant breadboard. So you basically attach all of your stages, and you can also mount your camera and different accessories like that. So you can use that. So you need X, Y, and Z stage. So what I use, and I'll show you, it's I use a milling table for my XY because it gives you a long range and distance. The one I use something similar to this device or this one. So you probably milling table. That's so you can get a huge range in terms of how you can move your transducer. So you don't have to be too limited in how your initial setup is, because the other ones only move like an inch. Like these folks here. Let me just go X Y Z stage. How about stage X stage? Um, these are not like these type of. They only move like an inch maximum, so they're kind of really hard because you have to really align your device very well initially. These ones move around 3 or 4. The one I was showing you earlier moved about 3 or 4 inches in each direction. We can actually check, um, and you can also buy different sizes. You can buy the large version, and adjusted in Y direction is 50 millimeters, but the X direction is 180. So that's really great. It's about 5 inches or so. So it works well, and you can also mount your sample. You don't have to be limited to the optical table setup. There's more traditional ways to mount, and those are like you would for machining, but except you're not going to be machining. Um, so that works excellent. Let's see here, theta stage. So let's take a look at theta stage. I'll show you one that I've used before. I don't want to go there. And I found this one. So milling theta. Okay. Something like this, adjustable tilt. This is good. Adjustable angle plate. Angle clamp. I'm not finding it right now. I'm not finding it right now. So milling. I'm just gonna look for a little bit longer. Hold, hang on with me, because if you need this, you're gonna need it. I think I got it from Amazon, to be honest, because they have a lot of vendors, and there's hopefully no risk. The good thing about buying from Amazon versus eBay, there's no kind of, or other place, sometimes other places, there's no risk for getting your payment information compromised. So this is it. Aha. This is what is going to be work really well for rotary milling table. Okay, that's it. Let's see if we can get it better. Rotary milling table. Let's search for that. And that's going to allow you to stick some method of your transducer. And it's kind of freezing up here. No worries there. Rotary milling table is what you might need if you're going to, this is perfect. If you're going to stick your transducer and you need to actually change the angle and also rotate it around, that's going to be useful. You might need to design a holder for a specific transducer you're using, but it's going to work really well. I've used it personally. Okay, so let's talk about clamping. So every transducer is going to have its own method that you're going to need to clamp and hold it. Some transducers will already have it hold it on them, like a fully built transducer that's almost ready for the customer per se. But if not, you'll need to you'll need to create or make a holder supporting the transducer by its nodal points. Um, Oftentimes you can use like foam to hold it if you don't want to have it exactly at the nodal point, but you'll still have to have a way to clamp it, which is going to be, you'll have to work with it, I guess, if you use clamps, if you attach it with some type of, you know, that's why actually, honestly, that's why the stage is so important to have a long stage range, because after you clamp your transducer and you put it in some type of foam and you're testing it for its displacement, you're not easily going to be able to control exactly where it sits. You'll need to tape it down with something to some. So you can, for example, a good option would be taping it down lightly to a piece of foam, which is maybe stuck to another platform. So you could get hot glue. You hot glue you foam to a platform, small platform, and then you put your transducer on there, and you find some way of taping it down temporarily, so that you won't have disturbance of its resonance. But the best thing is kind of just to have that incorporated clamp into your transducer already, so then you won't have trouble holding it. The other topic here is horizontal versus vertical. So I showed an example with this device. Let me just show here. So the transducer is going to be right beneath here. Like this is the measure. This is the circuit board that's being measured. But the transducer is going to be under there. So you're going to be measuring. You're going to be looking down at the transducer. You can also have it in the case where you're looking forward to the transducer. So the transducer is kind of, you know, if this pen was the transducer, it would be pointed out like it would be pointed outward or straight versus versus flat. Um, it's still the same, and depending on which side is resonating. So if it's resonating straight out or if it's like bending, you'll want that motion obviously perpendicular to your camera. Um, so you'd be able to actually measure, because cameras just measure in you know, plane measurements. So you'll have to look at that. It depends on your lighting, on your setup, which is going to be better. Um, I've seen a lot more industrial companies using horizontal base placement built on an optical breadboard. I don't have that to show here today, but either way will work if you have it horizontal like this, like a typical inspection, or you have it horizontal. Horizontal is actually necessary when you have the thing in water, because your transducer will have a cup or so. You'll stick your transducer in the water and you'll measure it from the side here. So you'll need to do it for water if you have an in-water measurement. Otherwise, I guess you are more free to do what you want. But there's nothing that says that you can't just orient this whole thing sideways and do it from there. But it's just not as obvious. Okay. Lighting. There are a couple of ways to light your transducer. One is from behind. Um, you shine a light from behind your transducer, and there's a couple of kind of optical sources here. And I'm going to actually, and bear with me here, the zoom video is kind of like, this menu is at the top. Move it down, or I don't care about it. Okay. Let's go to Thor Labs. It's useful to walk you along. I know, I think you can do fiber optic lighting. If you do, okay, fiber optic. Fiber optic lighting scientific. Okay, so this is what gooseneck light. Okay, yes. These are what is used a lot. You're able to, I'll just click that. This is what you can use for lighting your transducer. It'll have some type of bulb here, and that's going to provide a sort of point source light to your transducer in order to illuminate it. Um, um, Another thing you can do or search for probably is, let's search for, I used to use Bing. Let's see how it works. Machine vision backlight. Let's look at images and I'll describe what is useful. So yeah, these are like, for example, this whole thing illuminates like it does here. It becomes green or red. It doesn't really matter the color per se, but you put them behind your transducer, and it shines light, and then there's a blur that occurs from that process. Um, or you can shine a light onto the transducer, and what reflects back is maybe like specific angles, specific points where light is strongly reflected based off of the shiny surface, where you perhaps made a scratch on purpose, or you just kind of move the light around in order to highlight a certain point, or you shine the light from the side in order to just to make the edge of the transducer make the edge of the transducer highlighted or illuminated very sharply, so you can determine a blurred edge from that. So machine vision backlight is another option. Um, then there was that. I wonder if they have it on Amazon. Yeah. I just get a lot of things from here because it's kind of simple. They do have it. Look, this seems like what does it look like when illuminated? Sorry, I'm doing all of this when I'm here. Okay. Dimmer. I don't know what is light pad. I don't know what it is. Oh, you just draw on it. These do not look like it. Do they have gooseneck? So gooseneck light LED. So these are just consumer products, right? What did I search for? I searched that came up. I can try this here. Honestly, any light is going to work, but what you would want to do, and this is all consumer stuff here. What you'll want to do is, and we can look up, we can put that same thing in here. Yeah, and these are obviously broadband halogen fiber optic illuminators, and that sounds like expensive. Um, let's see how expensive this is. Yes, $1,000. Not much, but we're not running that type of operation that you probably won't need that. But if you do have it, that's cool too. Okay. Um, and I will show you this thing, this light that I have, which actually works kind of well. And the reason is, and I'll show you, it has one LED on the front, which kind of makes a point source, which allows the camera not to get overwhelmed, so you don't have the whole entire surface illuminated and with too much light, and you also don't have light coming in from different angles, which is going to make the image more fuzzy. It's better to have a single point source, which it approximates. You can use any type of LED, but this approximates a point source and it's a rechargeable battery and whatnot. So work light LED. This is what you can search for, and it will come up here. This is the one I have. Has magnetic base. So it works. So I use it. And I'll show kind of its use in a couple minutes here. Not a couple minutes, I mean in future episodes. We are moving on to background light, point source, that's better. Just a plain old LED was also going to work just fine. Okay, let's put that down there. Like SMD LED. Don't get those little tiny, like little. Get SMD LEDs if you're gonna get one, and have them pre-wired. So this is something I have, and I hope to show you soon. These are just pre-wired SMD LEDs. Looks like that. Okay, my head's in the way. Maybe my head. There it is. There it is, right there. So that's just the LED. You can attach it to something else, maybe with hot glue or something, and there you go. You're off to the races. Illuminating your sample. And sample prep. So typically, in order to make your surface that you're trying to measure shiny or like kind of reflective, you may put a sharp scratch in it with a blade or kind of maybe a stroke of sandpaper Sometimes that's not necessary if you illuminate the tip only. Like you shine it in a certain way, you can capture a spot of light already. I'm not going to be showing that here today in this video, but definitely I will demonstrate that work. Also, um, that's about it. So you kind of just kind of maneuver the light around and you find what works best and what illuminates a nice edge. And I'll go over some of that with you guys. Finally, okay, so let's talk about software. So you've acquired this image. How do you analyze it? A lot of inspection, machine vision, let's say inspection softwares that you manually do measurements from, those will work very well. Sometimes the manufacturers of these systems, like the cameras, will have their own inspection programs. For this kind of Chinese company that I bought the camera that I have on, it came with a program that you could use for manual measurement. So you pick a spot here and you move it around. That works. You'll need something for calibration. So let's go over that. So optical calibration. This is reticle calibration microscope. I said microscope. Microscope. So these are, there's a lot of different you'll need so different microscopes have, so that's 0.0001 millimeter divisions, and you can put this you can take a picture of this with your microscope. This is a transparent, doesn't have to be transparent. Basically, the nice thing about these microscopes is wherever the focus is, you just have to calibrate it one time and then just get your image in focus. And now no matter what height or anything, if you use the same zoom setting, you'll have the same microns per pixel setting. So that works perfectly. But basically, microscope calibration, and obviously you're measuring things in the 10 micron range. You could also, basically the maximum size that you can probably fit in your field of view would be perfect. Sometimes there's squares or circles or just kind of dashes, kind of markings that will give you that microscope calibration. Optical is kind of like overkill. Like this works like this. These will be calibration slide. Oops, that's even better. I don't think I need to show anymore. Basically, calibration slide is going to get you there. Then you can use a lot of just general image analysis programs. I'm going to use a program soon called ImageJ, and I'll demonstrate how that works. But basically, you can form a histogram similar to how I showed in a couple of videos before for my program. You can form that histogram of the pixels in that program. And I'm also developing myself, obviously, stroke analyzer to do all of this automatically, to kind of take the pain of all of these visual measurements and make them automated and easy. Who wouldn't want that? So again, kind of going over things top and bottom. We talked a little bit about the camera. Clearly admit I'm not an expert in choosing your camera and your optics, but those are some things to think about. You'll probably want to talk to the supply if you really want to get, if you just want something to get going, then you'll probably want to buy a similar product that I did that came in a full solution that was relatively inexpensive. But if you're trying to push the edge of what can be measured, and also if you have a manufacturing operation where you need to have basically products and to be purchased products with serial numbers and being able to calibrate them and trace their manufacturers, kind of have a more legitimate product line or chain, there you'll want to go with the standard suppliers for those products that have been around for a while, so you can get support if there's any problems, and you can obviously get part numbers and calibrations of products for those, and they'll be built under some type of kind of manufacturing standard, which is perfect and necessary for companies in production environments. I talked about stage, which is really important. Milling machine stages are the secret. to having really great stages that give you a long range of XY motion. Otherwise, it's very annoying. Lighting is important. I mentioned like work lights, gooseneck, fiber optic illumination. I also mentioned just LEDs, even simple things like this, a rechargeable work light. This works quite well. It also has red, which probably is not useful, but it's there. I want to be showing. I hope to be showing you guys um, uh, a strobe light, so that that'll be cool soon. So, and also the software options that are there. I'm gonna be going more into the software and actually all of these areas, perhaps except camera and lens optics. Um, but the rest of the areas definitely I'll be able to demonstrate for you to give you a little bit about what my experience is, and as I kind of also start to set up my own system there. And now that you've made it this far, I might kind of shift things. Actually, I won't shift things around and show you my system today, but I do have a system to show and demonstrate, and for you to copy if you want to, and to work along with your transducer and measurement solution. And I'm happy to take questions and answer and be of help to you as you set your system up. All right. Thanks for watching. This is episode number 60 of the Piezo SHOCK Show. If you need help and assistance in your development of your ultrasonic transducer, please reach out to me. There are links in the comments, as well as a link to get updates for when any of these videos are released. Not only the YouTube subscribe button is gonna give you that, but you'll also get these presentation notes in your email, so you'll know if you want to kind of dig in deeper into what the videos have to offer. All right, thank you for watching. I will see you next time in episode number 61.